Hi, I'm Naomi. This is how C-Trees moves from science data to a product platform, and how we use cloud-native geotechnology. I am the head of engineering at C-Trees. What C-Trees does is we're a nonprofit organized organization focused on tracking carbon emissions and forest change. We have high-resolution global data sets that are all in time series. So examples of our data sets are like above ground biomass at 100-meter resolution time series, tree cover loss, degradation with attributes like fire, logging, and roads, soil carbon, and tree height. And we have a group of scientists who create these models, and their outputs are all GeoTIFFs. And then we have our product team creating these interactive platforms. And so this presentation is mostly focused on how we go from these final results of the models to our interactive product. So this is an example of our Red AI. This is tracking logging. You have options on this of tracking fire and roads also. And what we're given from the scientists are GeoTIFFs that look kind of like that over there, right? On that right side of the screen, we just have colors. And then we perform zonal statistics, and that's how we get beautiful charts that show us actual actionable items. This right here is, this data set ran zonal statistics at administrative boundaries. So we have countries, states, provinces, districts, and counties. So the two major challenges we face. Raise your hand if you've ever been personally victimized by data versioning. Yeah, so that's something we face all the time. On our science side, we don't have a standardization on how to save data sets, and so to go from the data model to the product itself, we have to track down what the latest version is, and every single time there's a new version, we have to go message the scientist directly. The other issue that we face is, since we deal with time series, and on these GeoTIFFs, the time is not embedded in it, it's somewhere in the file name, it's not consistent at all. So we have to also message the scientist saying, where is the date, what's the correct format? And the other part is the metadata. Since we have classification data sets, we don't know what 1 is or 2, and so we have to ask for additional information. It's a lot of one-on-one, like trying to figure out how to get this stuff. And then the second part is the analysis limitations. We take the code from our scientists to do our zonal statistics, and I realized they use GDAL command line all the time, and they use some outdated GDAL packages. They use R, they use QGIS. It's not cloud native, they download all their GeoTIFFs, and there's no standardization of like what the inputs look like or the outputs. So, solution number 1 was using ArrayLake for our data management problem. So ArrayLake gave us a data catalog, it has version control embedding, metadata embedding, time series data cubes, and it's cloud native. So ArrayLake uses the ZAR format, and they use something called IceChunk to help with the data versioning. If you want to learn more about it, they have a workshop tomorrow, and I highly recommend attending. They're all wonderful people to work with. They walked me through how to set this all up. So what this looks like in practice at C-Trees is the one way that I could get this to work for us was to put it in a pip package, because all of the scientists are okay with running a function in a pip package. So when we went from a GeoTIFF format to a ZAR format, what we had to do was figure out the format of the dates, figure out the metadata, and I created a pip package that just has called ArrayLake tools, which has a function that's called populate ArrayLake, and it takes one JSON config that I have a scientist filled out, and it runs it, and it creates this beautiful ZAR data set that's saved in ArrayLake, where it has all the metadata embedded, it has a time series so we can grab it however we want for analysis, and it's all stored in ArrayLake. So that's kind of what it looks like. And then our second issue was not standardized functions across science. So what I did here was I took all of these multiple functions that were R, GDAL, everything, and I transfer them all to use Xarray. So Rio Xarray helps you with zonal statistics, it helps you analyze data, and so I created these like basic functions that I put in this pip package that have like processing geometry, clipping, reproject match, merging things together, and then calculating zonal stats. So this is how we got from the data into actual data sets that we could use for graphing and mapping. So in practice, The code is very simple. It's only a few lines of code. Up there, you can see that we get the data straight from Array Lake, so it's completely cloud native. Anybody can run this anywhere. And then we have this clip to geometry. And then our stats, because the metadata is embedded, our outputs have the names. And so instead of having a CSV that you have like 1, 2, 3, and you have to find the metadata to match it, it's already embedded in the output. So this made it a lot easier on the product side to deal with this data. Also, with using Rio Xarray, this allowed us to keep the package small enough to host an AWS Lambda, because an AWS Lambda has a size limit. So this helped us make it so we can make it more dynamic with our data sets. So this is kind of what it looked like before and after. So before, all of the dotted lines was, I have to get this data directly from each individual scientist, and it's hard to get, and it's a very manual process just getting the data. And then we would create a static tile server for our map, and that was a heavy process because we used GDAL to tiles for that, and every single time our final production version 1 was updated to final, we had to run this over and over again, which is also a costly operation because this is high resolution at a global scale. And then the second part was the zonal statistics, which we saved in our database. We would have to have custom scripts for that so that we could get it into a standardized format because all of these looked differently. So with the adoption of Array Lake, we were able to remove the static tile server completely because they have a web map tiling service. And so we could get rid of that step. And then with our conversion, having the scientist write to Array Lake with the metadata and the GeoTIFFs, all that information embedded, we didn't have to go through that process of asking what's the latest version because it's all inside the data itself. We were also able to take the C-Trees kit and host it in an API using a Lambda function, and this allows us to have more dynamic data flows. And so with this new updated process, we could even have the option for a user to give us data that we can run the analysis on, instead of a straight one-line way of us just giving them data. And so, yeah, and how I implemented this was just putting most of it in a pip package so that the scientists can use it easily. So this is kind of what it looks like in practice. Array Lake is our data management service, and so we get that metadata up there, and then we get the classification values and the WMS from Array Lake, which is really nice. And then we perform our zonal statistics using our C-Trees kit pip package that's hosted on AWS Lambda. So why is this important? C-Trees is a data provider, and it's really important for us to have transparency in how we're doing our analysis. So one of the reasons why I created C-Trees kit was so that we could show it, it's public, anyone can see it, so they can see how we're getting to our conclusions of how project sites are doing with carbon emissions and such. And then we wanted a way to deal with dynamic data, and we wanted a way to dynamically update everything and have users give us data that we could run analysis on. And so moving everything to cloud native was the way to do this. And then Array Lake allows us to scale our data sets because we created a standard, so any classification data set is called classification, and it can run the exact same stats as any of our measurement data sets. So we can easily add data sets to Array Lake and run it on anything. And then the future is, right now we focused on that data to product side from that data sets. We want to be incorporating Array Lake and ZAR into our science to data platform, so the science side where they're running the models, because right now they're still using GeoTIFF, so we're hoping to move everything over. Adding more functions to C-Trees kit and incorporating EarthMover just released Flux, which is also really good for analyzing data. Scaling out C-Trees kit to use Dask. And on the science to data side, using foundation models. And if anybody is interested in helping C-Trees out, please contact me. Yeah, so feel free to connect to me on LinkedIn, especially if you're looking to build out a foundation model. This is the GitHub repository for C-Trees kit. It's functionable. If you're interested in moving from ZAR or from GeoTIFFs to ZAR, reach out to EarthMover. You can also use this repository as an example of how to get there. Any questions? Oh.
how hard is it to go from GeoTIFF to ZAR?
It is 2 lines of code in my pip package, so not at all. So there's different, so it depends on your use case. For this particular use case, I've had, our GeoTIFFs are a single like mosaic time series, so it's 1 GeoTIFF per region per year. And that was extremely easy, like that was like 2 lines of code. I'm in the process of adding like tiled GeoTIFFs, so a folder of thousands of GeoTIFFs per year. And so that's the next process, which is a little bit more complicated.
Hey, thank you for your presentation. It was super interesting. I had a question about kind of like more your general observations. It looks like, if I understood correctly, you created C-Trees Kit to kind of abstract away some of the cloud-native tools from scientists and also for reproducibility, which I like super admire. But I was wondering if you had observations like, what would it look like if your science team directly like worked with X-ray and like we didn't have this level of abstraction? And are there like things that you think it could, like the cloud native community could make it easier for like science to access these tools? Or did engineering like always have to build a layer on top?
So there's 2 different, our scientists are kind of split up into 2 groups. There's the ones that use R and would prefer like a no-code framework over learning Python. And then there's the ones that use Python. So we're in the process of transitioning actually most of them to using Xarray. One of the main reasons I have C-Trees Kit is actually just to access the data from ArrayLake and things like that. But some people, it's easier for them to kind of go closer to a no-code framework, and especially since we're putting this kind of in an API to make it faster and run on demand. Yeah, so both of those, yeah.
This was awesome to see. I actually had no idea what's behind C-Trees, so it was super cool. I actually use C-Trees occasionally to find, working on field boundary stuff of like, I want to show EUDR use cases.
Yeah.
So I've used C-Trees just hitting the WMS directly like in QGIS.
Yes.
Do you have other availability of the data than the WMS?
Not right now. No, I think you'd have to contact, so we're a data provider, and right now all of our data sets that we provide easily accessible are just already aggregated versions of it. So like our Red AI, I don't know how to stop presenting this, but this tool here, it's aggregated at like the country level and then the state level. Access to the raw data, I think we're in a process of trying to figure out how to serve that out, but we have contracts with people in particular to get the raw data too.
Okay.
Yeah.
Are you planning to make it's fine if no, like are you planning to make the raw data available for the public?
If we get funding enough.
Yeah, okay.
So if some company has a lot of money, wants to give it to us, we're willing to do that. But right now, since we don't have that type of, right now it's like how we survive as a company.
No, that makes sense.
Yeah,
That wasn't
we
like,
want to actually. So that's the goal, was to have a completely open data source that anyone can add. So we're hoping that that type of funding comes through so that we can do this and provide it out.
yeah, this wasn't a like you should. It was more like I was able to use the WMS and that was great.
Yeah.
And many things would be nicer. I mean, and with like the nature of this data, like I'm sort of curious, like this is what I use. I just pull the WMS directly, hope that was okay.
Yeah.
But like if we could even vectorize that and turn it into GeoParquet, because that's a lot of what I want to do is just like intersect with fields, you know? Like when was this field deforested from a field boundary output, and yeah, so anyways. Cool.
Yeah, I haven't thought about really vectorizing it. Our engineering team is rather small, so that might be something interesting. I'm personally more of a vector person, so I'd be interested in doing that, yeah.
Cool, yeah, I am originally a vector person for 10 years, went to raster with Planet for a while, but now I'm like much more psyched on vector. And I was like, oh yeah, I like this one. So, awesome, thanks so much, it's a great project.
Thanks.
Interesting presentation, thank you for that. My question is related about the movement in terms of the spatial scale. If you got moving up and down, how you drill down up, roll it up, or you could go more granular. What are the challenges you think, by adopting the ZAR, could you quickly, change the spatial resolution depending on your needs? And what are your thoughts on how to deal with those challenges? Thank you.
Yeah. So when doing analysis, when we overlay multiple data sets, we use this Rio X-ray reproject match, and that's really easy to scale, like from our 100-meter to our 30-meter resolution to do analysis. It's really easy to run on our data sets. But one of the biggest issues with data sets, the WMS service, since this is a global data set trying to load like 5-meter resolution or 30-meter resolution, it'll take a while to load, and if it loads at all. And so setting up something, one of my goals is to have like pyramiding on our stuff and using maybe a static tile server for the first, like the global views. Currently on our website, we are using static tile servers. It's great for the global views, but once you get down to the granular ones, like it's so expensive to host because it's so many images. And so having like a combination of both would be way better at this. Yeah, and then going between different data sets. So we're still in this whole process of the zonal statistics, going from like a 30-meter to a 100-meter resolution data set and working through that, you have all this uncertainty. And that's actually something I need to add. Like that's one of the functions I plan to add to this is like, once you do that, how to calculate the uncertainty, how to like make sure that it's really transparent of like what data we're losing, what data we're keeping, yeah.